Greetings once again. Welcome to another edition. In this session, we'll be looking at the November 2023 Mathematics Paper 1, specifically question number 4. So question 4 is based on graphs, as you can see on the screen. And in this case, we find ourselves having an exponential graph. So let's quickly dive into the first question and have a read. Then we'll look at the graph and see what is going on. So the first question, 4.1, reads, write down the equation of the asymptote of f. So f is the graph which is given by that equation there, which is f of x. So let's quickly write down the equation. It is f of x equals 2 to the x minus 4. And what they want is the equation of the asymptote. So now the general question which you should ask yourself is, how do you determine the equation of this asymptote? So I'm just going to give you a general rule. So generally, for exponential functions, what you'll have a f of x equals, let me say, some constant a, then b to the power of x plus c. So whatever which comes here is your asymptote equation. So y is equal to c, whatever which is there, which you are adding, that becomes your asymptote equation. So which means for the problem which we are faced with, if you look carefully, you have that f of x, which I'm just going to rewrite. You have 2 to the x minus 4. What comes here is what becomes our equation of the asymptote. So the equation of the asymptote will be y equals negative 4. So they would give us marks there when we just tell them in conclusion that y is equal to negative 4 is the equation of the asymptote. So that would be our answer. Y is equal to negative 4 is the equation of the asymptote. And one important point is that your graph or the graph is not supposed to touch the asymptote. So remember, an asymptote is a line which you are not supposed to touch. So we should know that the graph f of x is not supposed to touch the asymptote. So that is just a side note which you should remember generally, that our graphs, they get closer and closer to the asymptote, but they never touch the asymptote. Okay. So let's now go to the second question. If you look at the second question, they say determine the coordinates of B. So when we look at our graph, you see where B is at. If you look carefully, the O there is for the origin, meaning that is where we have 0 and 0. So B, if you look carefully, it is on the x-axis. So let's come to this side. So if you look carefully, this B here is on the x-axis. And we are looking for the coordinates of the coordinate of B. So what this means is, since we're looking for the coordinate of B, and our B happens to be on our x-axis, what this means is is that all what we are looking for is the x-intercept of the graph of our f. So that is what we will be looking for. So our f of x is given as 2 to the x minus 4. And when we're looking for the x-intercepts, by now you should remember that when we're looking for the x-intercepts, what we do is we equate y to 0. Always do that. So wherever we see our function, remember that this is just the same as y. So it means we are just going to equate it to 0. Then have 2 to the x minus 4. And when you look carefully, I can transpose and have a 4 is equal to 2 to the x. And 4, I know I can write it using base 2. 4 is the same as 2 to the 2, and this is 2 to the x. And by now, you should remember that when we have the same base, what do we do to the exponents? We just equate them. So what this means is that the x value will be 2. But we know that the y value at b will be 0. So therefore, our coordinate for b will simply be 2 and 0. That is our coordinate for b, and that concludes 4.2. Finding the coordinates of b. So let's go and read the next question, which is 4.3. 4.3 reads, determine, let's use a different color, determine the equation of k, which is a straight line passing through a and b, in the form of k of x. So let's have a look at what is going on. So they are saying there's an equation which we need to determine of a line that passes through a and b. So let's quickly copy that and paste it on the next page and see how do we find that. So what is going on is we need to find the equation of a line that will pass through these two pink points. So essentially there's a line that will go like this. And that line, when you look at the expression, they are saying it should be k of x. So that line will be described by the equation k of x. So already the coordinates of b, we know that we have 2 and 0. But when we look at the coordinates of a, we have not found what a is. And if you look at a, it is what? It is the y-intercept, because look carefully, that is the y-axis. So if you look at point A, the coordinates of A are centered, or they are on the y-intercept. So, and we know that when we are looking at the y-intercept, our x always becomes 0. So our equation, remember, is f of x equals 2 to the x minus 4. So why am I looking for the coordinates of A? It is because you need at least 2 points for you to be able to find the equation of a line. So if we get point A, we can now find the gradient, then find the C, and so on. So if you look carefully, what we will have is f of x, we'll put in wherever we see x, put 0. So we'll have 2 to the 0 minus 4. 2 to the 0, we know it's 1 minus 4. So this becomes negative 3. So what does this mean? It means that our a will simply have a value of 0 for x and negative 3 for y. And our b, remember, we found as 2 and 0. So we can now find the gradient of that line. And for gradient, we remember that it's change in y divided by change in x. What does that mean? It means we can do the y of b minus the y of a divided by the x of b minus the x of a. That is how we are going to find our gradient. So our gradient is going to be the y of b is 0 minus the y of a is negative 3. So all of these should be divided by the x of b is 2 minus the x of a is 0. So if you look carefully, our gradient will end up being 3 divided by 2, because the negative and the negative there will end up making a positive. So that is our gradient. And then we can clearly see that our c will be there. So our c value will actually be negative 3. But let's go ahead and just do the work a bit manually. So let's go to the next page. So let's get to this page and quickly find our expression. So remember that they said we should represent it as k of x. And we know the equation of a straight line is always mx plus c. So we can use one of these coordinates here to be able to solve for c. So let's use a. So the y of a is negative 3. The m is 3 over 2. The x is 0. Then plus c. You will see that this here will amount to 0. So our c will be negative 3. So this means that the final equation k of x is simply 3 over 2 x minus 3, like this. This is what the final equation k of x is, and this answers question 4.3. I hope this does make sense. Just make sure that you understand every step which we took here to get to the final answer. So let's go to the next question. The next one, they say we should calculate the vertical distance between k and f at x is 1. So at x is 1, we need to figure out what is the distance between k and f. Okay. So let's go ahead and see what is going to happen here. And this is 4.4. And for 4.4, let's quickly copy that graph. Then remember my k of x has a point here and here. And it is a line passing like that. And we have k of x. In fact, let me write what it is. We pull down the equation here. So k of x we found is 3 over 2 x minus 3. So we know that our b here is at a coordinate of 2 and 0. So x is 1 is somewhere here. So x is 1 is somewhere there. So essentially what we are looking for is the distance between the two functions. So it is that purple distance. That is what we are looking for. So what is that purple distance? At x is 1. So what I'm going to do is I'm going to write my f of x, which is 2 to the x minus 4. So I'm going to try and find out what is the y value of the pink function at x is 1. And I'm going to try and find out what is the value of our black function, this one here, the f at x is 1. That is what I'm going to do. Then when I have found the two values, those y values, I can just subtract them and then I'll know the distance between the two. So let's go and find out what is our k at x is 1. So that will be 3 over 2 into 1 minus 3. And this will simply be 3 over 2 minus 6 over 2. And if you look carefully, this will end up being negative 3 over 2. Now let's go and have a look at our f at x is 1. So that is going to be 2 to the 1 minus 4, which is going to be the same as 2 minus 4, which is going to be minus 2. So essentially what we have there at x is 1, we have a graph, the pink one. Just throw them here. You have the pink one and then you have the other one, which is going something like this. And then what you have here is the distance, which we are looking for. And at that point, on the pink one, what we have at the top, remember x is 1. So you have 1, comma, the y value for the pink one. Let me write them in pink. So if you look carefully at x is 1, what we got was 1 and the y value was negative 3 over 2. And then for the bottom function, which is our f of x, x is 1, the y value was negative 2. And we can now go ahead and use the distance formula. If you remember, the distance formula is simply x2 minus x1 squared plus y2 minus y1 squared, like this. So what I'm going to do is I'm going to find that distance. So I have 2 points here. I have 1 in negative 3 over 2, and I have 1 in minus 2. So let's go and find our distance. So our distance is going to be, I take the x's, so it's 1 minus 1 squared plus, let's deal with the y's, negative 3 over 2 minus 2 all squared. So if you look carefully, what we will end up having will be negative 3 over 2. The minus will make a positive there, plus 2 all squared, like this. And this you can easily use your calculator to figure out what it is. So this will end up being just 3 over 2. Sorry, it will not be 3 over 2. It is going to be a half when you add that and then squared. So finally, you will square root the square of a half, which you should be able to see that the d will end up being a half. So our distance is essentially 0.5 units. That is the answer that we're expecting us to be able to provide for 4.4. Right. So let us now go and jump to the next question, of which it is 4.5. And 4.5 reads, write down the equation of g if it is given by f of x plus 4. So we're looking at 4.5, and they're telling us that g of x is the same as f of x plus 4. So what we should remember is that f of x was given as 2 to the x minus 4. So therefore, our g of x will be 2 to the x minus 4 plus that 4 which they put there, and you'll see that the 4 and the minus 4 will cancel and we'll be left with 2 to the x. So essentially, our g of x is simply 2 to the x. Okay, so let's jump to the next question, which is 4.6, and the question requires us to write down the domain of g to the negative 1. So g to the negative 1, all what it means is that it means the inverse of g. That is what it means. So we are required to find the domain of g, or the domain of the inverse of g. So my advice when you get these questions is that always start by finding the domain of the original function. So find the domain and the range of the original function. So always start by doing that. Find the domain and the range of the original function. Then you'll stress about the inverse later. So when we look at our g of x, which is 2 to the x, what we can clearly see is that for the domain, remember that the domain, it is all the possible, what you would call it, x values. So for the domain, we can clearly see that there's no x value which we are limited to. So you'll just say our x is an element of real numbers, because our x can be negative numbers and positive numbers. But remember, our y will be restricted by our asymptote. So since we do not see anything, we put in plus 0 there. And that 0 becomes our asymptote. And what does an asymptote mean? It means it's a line which we should not touch. So this means that our range, which the range, it's the possible y values, our range will be an element from 0 going up to infinity. This will be our range. And when you now deal with the inverse, it becomes easy, because when you are dealing with the inverse function, the range of the original function becomes the domain, and the domain of the original function becomes the range. Okay, so let me make a note of that, and then we conclude this. So when you are now dealing with your inverse, so let's make a note when dealing with the inverse, which is usually denoted by G negative 1, it can be F negative 1. What happens is the domain of the inverse is actually the range of the original function. Okay, and then the range of the inverse, which is G negative 1, is actually equal to the domain of the original function G. So remember that what we wrote above here, these are for G, the original function for G. So now, because they were asking me to write down the domain of the inverse, and I can clearly see that the domain of the inverse is actually the range of the original function, I can easily give them the answer. So let's write that in red as the conclusion. So I'll say answer. So the answer which we are supposed to give them is that the domain of G minus 1, which is the inverse, what it is we have Y is an element. So what you do is you switch the domain for the, I said we are looking for what? The domain. So we'll switch the domain for the range. Because we switch X and Y, because we're dealing with the domain, we'll put in X. But what we'll put in is the condition for Y. So X will be an element from 0 up to infinity, like that. So that becomes our answer for the domain of the inverse. Okay, so let's have a look. After, in fact, carefully looking at this, we have a correction which we need to make here. There's something which is very important, which you were not supposed to miss, which I nearly missed. So look at the dot there. So what is going on is our function is defined between these borders, there and there, the original function. So the original function is defined within these borders. So our answer for 4.6 will change slightly. Okay. So let me give it a shot again. Right. So let's quickly have a look. Maybe I do not need to even erase all of this. Okay. I don't. So let's have a look at why I do not need to stress. So I only need to remove the answer and what we have there. So if you look at our original function, it was bounded, or the domain was between -2 and +4. So that was the domain of the original function. So this new function, if it is just an addition of the original one, remember the 4 here, what it does is it changes whether we go up and down. It only changes the asymptote. It does a vertical shift, but it doesn't do anything horizontally. So as it stands, the domain of g of x, what you should be able to see is that it's going to be an element. If you look at that one, the -2, it is included, so it's shaded. So I'm going to have -2 like that, up to if you look carefully, 4 is not shaded. So that's why I'm going to not put in a square bracket like that. So that becomes our domain. And then if you think carefully of the range, if you think of the range of the function, the range will actually be affected by the domain. If you think carefully, because if the domain is restricting the function to have a minimum x value of -2 and a maximum one of 4, then it means that when I'm looking at my range, I need to go and find g of 2, which will just be 2 to the -2. And this will be 1 over 2 squared. This will be 1 over 4. Then if you look at the other one, I'll have g of 4, which will be 2 to the 4, and this will become 16. So if I quickly now put in our range, you should see that the range will be an element of, I will have 1 over 4, and then the 16 I will exclude, because the 16 I got it using our x is 4, and x is 4 is not included. So that becomes my range. Then the same principles which I was alluding to now apply, that the domain of the original function becomes the range of the inverse. So let me see if I can create some space here. Then let's go ahead now and deal with the inverse. So what you should remember is that the domain of the inverse is the same as the range of the original function, and the range of the inverse is the same as the domain of the original function. So let's quickly finalize our answer. So remember that this domain and range which we're working above here, they were for g. So I'll state that these were for g, and this also was for g. So now, because they are looking for the domain of the inverse, it means I just need to look at the range, and that range becomes my domain. So if you look carefully, the domain of that inverse will simply be the range. So it will be x is an element of our range, which is 1 over 4, and 16 excluded. So that is how we find the answer for 6 or for 4.6. So let's now dive into the last question, which is 4.7. And 4.7 reads, write down the equation of the inverse of g in the form of y is equal to something. So let's go to the next page and do exactly that. So the original g of x, which we have, is simply 2 to the x. And remember that when they speak of g negative there, all what they are speaking of is the inverse. And how do we find the inverse? How you find the inverse is easy. You swap x and y. Okay, so what does this mean? It means that if you look carefully, originally, what we have is simply y equals 2 to the x. Now, when I'm working or I'm looking for the inverse, I'm going to swap x and y. So where there was y, there's going to be x, and where there was x, there's going to be y. Then what I need to do afterwards is to just solve for y. And the y which I get there becomes my inverse. So if you remember your log laws, whenever you have a base like this, you can just introduce log, and that base becomes the base the other side. So essentially we'll have y equals log with base 2x. So this is what they were looking for, and this is the inverse of our original function g. So make sure you remember that when looking for the inverse, you swap x and y, then you solve for y. And just like that, you would get all these marks which are here. I hope this does help. Just make sure that you practice and practice and practice. Most importantly, make sure that you have a look when they give you or when they restrict your function. This we nearly missed, and our answer was going to be incorrect because we missed that or we didn't take it into account. Okay, cheers.